Bismillah ar-Rahman ar-Rahim. This is an example about the free fall. Okay, it talks about a balloon. You know the balloon, the passenger's balloon, and the balloon is moving upward, or sometimes we say it is ascending. Ascending is moving upward. Sometimes you see it is descending. If it is descending, it means moving downward. But here, in this case, it is ascending. Okay, let me write it for you. Ascending means moving upward, and it is moving at a constant velocity of 10 meters per second. Okay, so the balloon is going up, and passengers are there in this balloon. When the balloon is 100 meters above the ground level, one passenger releases a stone. Okay, so he has a stone in his hand, and he just releases this stone. Okay, would like to ask few questions. Number one, A, find the final velocity of the stone just before it reaches the ground. Okay, just before it hits the ground. Let me ask you one question. Can you describe the motion of the stone? What will happen to the stone once the passenger releases the stone? What will happen to the stone? I guess some of you will think that the stone will start moving downward immediately. But notice one thing, the balloon was moving upward, okay? And everything riding in the balloon, passengers, the stone, luggage, everything, will have the same speed as the balloon, okay? So what is the initial velocity of the stone when it was launched or released? It will be the same initial velocity as the balloon, okay? So to describe this motion correctly, this stone, as we said, the passenger has released it. So relative to the balloon, it was released from rest. But relative to the ground, it is not starting from rest. It has started with a velocity upward 10 meters per second, okay? So it will be moving upward until it reaches final velocity equals 0, or maximum height, because there is deceleration, free fall, it will decelerate, okay? Then it will come back and it reaches the ground. So what is given here? V initial is equal to, don't say it is 0, because you think it is released from rest. Yes, relative to the passenger, it was released from rest. But the passenger, the balloon, the stone, everything was moving upward with 10 meters per second. Okay, so it is plus 10 meters per second. This is the V initial. V final would like to know. Okay, what else would like, or we have? We have delta Y, which is Y final minus Y initial. Y final is here at the ground level. Okay, let us say it is 0, and Y initial, it is given, it was 100 meters, okay, at this point. Okay, so what is Y final minus Y initial? So it is 0 minus 100, so it is minus 100 meters. You see, it is negative, because my object finally ended at a lower height than the initial situation. Some of you might think, oh, what about this part where the stone has gone up? It is not included here. Yes, it is not included because this is displacement. Okay, delta Y talks about the final vertical position and the initial vertical position. Okay, regardless what happened in between. Okay, we focus on the Y final and the Y initial, and we don't care about this details. Okay, and the acceleration, it is a free fall, so it is minus minus g, which is minus 9.8 meter per second square. So we have 1, 2, 3, 4 physical quantities. 3 of them are known, and the fourth is unknown. Okay, I think it is clear here that we can use equation number 3. Equation number 3, if you remember, V final square minus V initial square equals minus 2G delta Y. Okay, so V final, or I can take this to the other side. So V final square equals V initial square minus 2G delta Y. So V final will be square root plus or minus square root of V initial square, which is 10 squared minus 2 multiplied by 9.8 multiplied by minus 100. So minus will go with that minus, so this will be plus. Okay, I hope you are following. This delta Y is minus. Okay, with this minus it will be plus. So which one should I choose? Should I choose V final to be plus this much or minus that much? See, it will hit the floor. When it hits the floor, or just before hitting the floor, the stone will be moving downward. Okay, so we have to get rid of the plus side. So the final speed will be downward, and the magnitude of that is minus. So V final will be minus 45 meter per second. Nice. What is the magnitude of the velocity, or what is the speed? It is 45. What is its direction? It is downward. Okay, so this minus sign is indicator of the direction, which is downward. Part B, how long does it take the stone to reach the floor? How long does it take the stone to reach the ground? Okay, he's asking about the time. So time is requested, so time is unknown. What do we have? We have V initial equals 10 meter per second. What else? We have the acceleration, which is minus g, or minus 9.8 meter per second square. And we have V final, okay, which is minus 45 meter per second. Okay, so we can use these 4 physical quantities. 3 of them are known, 1, 2, 3 known, and the 4th, which is the time, is unknown. Which equation should we use? The first equation, huh? So the first equation can give us the time. So use equation number 1. Equation number 1 says V final equals V initial minus G T. V final is minus 45 meter per second. V initial is plus 10 meter per second minus 9.8 T. And from here we can find that the time equals 5.6 seconds, approximately 5.6 seconds. Of course, you can do it another way. There is another method. Some of you might think to deal with time is unknown. V initial is 10 meter per second. The acceleration is minus g, and he would like to use delta y, which is minus 100. In that case, he should use equation number 2. But equation number 2, be careful. You will have t square and it will be quadratic equation. Okay? There, delta y equals v initial t minus 1/2 g t squared. Okay? If you plug in the numbers, you will have minus 100 equals v initial, which is 10, is positive, upward, t minus half 9.8 is just 4.9. Okay, t squared. Then you have to rewrite this equation in this way. 4.9 t squared minus 10 t minus 100. All of this is equal to 0. Okay, and you have to use the discriminator. This is a. Okay, this will be b. The coefficient of t squared is a. The coefficient of t is b, and the constant. This is what we call c. So you have the choice either to use the discriminator or try to train yourself how to use the calculator to solve such a quadratic formula. Let me remind you of the discriminator. Here the time can be found minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Okay, so we'll have two solutions for this quadratic equation. Okay, this is b. B is minus 10, c is minus 100, a is 4.9. Plug in these values and you will get the time. One of them will be 5.6 and the other will be minus or a negative time. So ignore the negative time and choose the correct answer, which is 5.6. Okay, I hope you understand this important example. Part C, find the maximum height reached by the stone. Okay, relative to the ground, relative to the ground level. As you can see here, the stone initially was at 100 meters, okay, when it was released from rest relative to the balloon. So it will go up. Would like to know what is this total distance or maximum height from the ground, okay? Would like to know this h equals how much. It will be 100 plus some delta y. So let me find delta y. So h, which we would like to find there, h will be 100 plus some delta y. Okay? To find this delta y, we know that v initial is equal to 10 meter per second. And at the maximum height, when the stone reaches this point, what will be the final velocity? It will be 0. Okay? It will reach maximum height when its v final is equal to 0. And we know that the acceleration is minus g, and would like to know what is delta y. Okay? So from here, we will use equation number 3. Kinematics, use equation number 3. For equation number 3, we know v final square minus v initial square equals minus 2g delta y. V final is 0 at the maximum height, and the minus will go with this minus. And from here, delta y will be 10 squared divided by 2 multiplied by 9.8, which is 19.6. This is approximately 5.1 meter. So from here, we will reach to the maximum height relative to the ground will be 100 meters, okay, the initial height plus this much, which is 5.1 meters. So the total will be 105.1 meters. This is the maximum height relative to the ground. Thank you.